Welcome to this course on Illumination Engineering and Electric Utility Services. Today we are going to take up lesson 10, which is titled Discharge Lamps 3. We've been looking at discharge lamps in the last two lessons, and as the name indicates, the lamps operate on the principle of a discharge in a gas or a metal vapor, and they use the physical processes of electroluminescence and fluorescence. The electroluminescence is essentially radiation by the arc discharge, whereas we found that when we are using a mercury vapor, we do have radiation in the zone which we call as ultraviolet. Recall that the complete spectrum of light can be categorized broadly into three groups: 1, the ultraviolet zone; 2, the visible zone; 3, the infrared zone. And in fact, the fluorescence works on the principle of absorbing radiation in the ultraviolet zone and re-radiating in the visible zone. So we had a look at some of these aspects in the last two lectures. We continue with the fluorescent lamps a little more in this particular lecture. One important thing which we observed was that no matter what type of discharge lamp you have, you need to maintain the arc discharge, which is a constant current phenomena and has to sustain the arc in the supply voltage variations which are inevitable. And that is where we need to have a device which maintains the current through the arc constant, and this is how we have one accessory brought in all these lamps in the form of what we call a ballast. It not only helps in creating the required higher potential in the beginning to have the arc struck, and the other important aspect which was to be noted with these lamps was, unlike an incandescent lamp, they do produce a band which is produce radiation which is band limited. It is not a continuous spectrum as it was an incandescent lamp. In fact, incandescent lamp would produce a spectrum which is quite close to the natural sunlight, and that is what we are looking at all our sources when we are trying to design the lighting systems. The aim is to bring as close to the natural light as possible and to make efficient productivity. Okay. So with this in mind, the instructional objectives for this lesson could be listed as: how are fluorescent lamps specified, understand how every watt of power is spent in a fluorescent lamp. Remember, when we moved from incandescent to discharge lamps, one interesting thing which enabled us to consider these was, notwithstanding the line spectrum, the good light efficacy. Light efficacy, recall, was talked in terms of lumens per watt, that is the light flux radiated for every watt of energy consumed. The other thing we say, the first objective says how are fluorescent lamps specified. We will look into it. In fact, you remember most sources were talked in terms of the nominal rated power consumption, and once we know the power consumption, we know the nature of lamp source, we also have an idea of the amount of efficacy that it has depending on the nature of physical process that it uses. Now, apart from using for illumination purposes, which we say is for viewing things or making objects perceptible to us, there are other applications of the ultraviolet light. We try to address that. That's why the third objective is state various applications of UV light. Now, the trend these days, all of us have observed these. There are what are called as CFLs, or compact fluorescent lamps. So we have a look at what these are, how they compare with the normal lamps. How do CFLs compare with ordinary lamps? So the lesson would be centered around this. So continuing with the discharge lamps, so we have logically taken, in fact recalling that there were 4 physical processes: thermoluminescence or incandescence was a body maintained at a higher temperature giving out radiation. Yes, we did get reasonably good efficiencies compared to Edison's incandescent lamp, but still the light the efficacy, luminous efficacy of an incandescent lamp is still very low, and that is what has driven us to look for alternate applications. And in doing so, we do recognize that the discharge lamps like sodium vapor and the mercury vapor, which we have exhaustively covered in the earlier lecture, are having good or high luminous efficacy, but do not have good color rendering. Color rendering, what do we mean? We mean color rendering, ability of perceiving the color in its original state. But we have recognized that there could be applications where we may not need to have good color rendering. It may be all right if we are able to get the objects in a macro sense, not worried about the details, and that is how they are useful. Continuing with the fluorescent lamps, the fluorescent lamps, the radiation depends on the current level. In fact, we said the luminous flux depends on the arc current, and oftentimes, in fact, the specification is what we are going to address to begin with. The people who have been using these lamps are not the common man, but the personnel working with the maintenance systems and architects and engineers are aware of a specification which is mentioned in terms of the tube diameter. It is often specified as T sub n, where n stands for the number. It could be T5 is a common thing which is being used. The important thing to be remembered, although it is a constant current thing, as the length of the tube increases, the voltage increases. Now here again another important issue which comes up. We had seen in the laws of illumination how the effect of light at a particular point, which we call as the illuminance, and we talk in terms of the lumens per unit area, that is lumens per meter square as lux. It depends inversely with the distance from the point source. Incandescent lamp could always be viewed as a point source. Now, as against this, if we consider a fluorescent lamp which has got a long glass tube in which interior is coated with phosphors, can be considered to be as a line source, in the sense that there are number of point sources placed edge to edge close by, and if we see the lux or the illuminance levels with the distance would therefore can be shown to be inversely proportional to the distance. And going this way, if you had a number of fluorescent lamps placed one close to each other forming a plane, you can view the source of light to be a plane source of light, and it can be proved that the light due to such a source on the work area is independent of the distance between the plane of the source and the plane of the working. So, in all interior applications where criticality is involved, we try to have as close to a plane as far as possible. Now, coming to this line sources, the issue which we are talking about is the required voltage. No doubt the variation in voltage is less, but increases as the length increases. The other thing is, however, this voltage has a certain decrease with the diameter. In fact, I told a little while ago, we talk for these fluorescent lamps in terms of the diameter. That is why we have a recent trend. We would like to use the tube diameter to the maximum extent possible, and that is where we have got what are called as slimline tubes. And in fact, the modern day energy saving fluorescent lamps are of very small diameter, and being a constant current phenomena, as the current level increases, it's got a negative current negative resistance characteristics. Voltage decreases as current increases. So, as I said, length and diameter play a role, and oftentimes designers ensure that this ratio of length to diameter is kept constant. So, in any fluorescent lamp, attempt is made to keep length to diameter constant, and that is a very valid, important issue. We have seen some of these fluorescent lamp based table lamps which are there. They have much thinner tubes than what are used for illuminating the rooms. Inherently, you will find at the ends brightness is low, and one can observe, this is a very important issue, probably around 6 to 7 diameters from the end. See, normal fluorescent lamp which we are using is around 24 mm, about an inch in diameter, which means about 6 inches from one end you expect reasonably uniform brightness to develop. So, that is why a very short fluorescent lamp tube may not be a very good idea. Okay. Now, coming to the specification, how do we go about? I said T sub n is a common way of specifying, and we are coming across in the market these days what are called as T5. We did mention a little while ago that the voltage decreases as diameter increases. Now, T16 I have shown would mean traditionally, in fact, the metric system, the French system was in use, which meant T16 would convert as a tube of a fluorescent lamp whose diameter is 2 inches. That means, if I have 16 as a number in the specification T16, you multiply that 1 over 8, that would be the diameter of the tube in inches. So, T16 would connote 2 inch fluorescent lamp, and that is how we would mention. And here, remember, this is still a discharge lamp which would expect a discharge in a gas, and recall it is the low pressure mercury vapor which is the. Now, in all gas discharge lamps, they depend on the electron emission. The processes that are responsible for electron emission are thermionic emission, electric field assisted emission, and photonic emission or impingement of light. And we have also said, therefore, fluorescent lamps could be of two categories, one which depend on thermionic emission called as hot cathodes, and they have small drop at the ends or at the cathode of the order of 14 to 16 volts, whereas if we had a cold cathode there would be a large drop. We did mention in the earlier lectures also that there would be a requirement of a higher voltage source in order to have electric field assisted emission, and is not. Therefore, the understanding of incandescence becomes even more important. We have a similar filaments at either end which are heated by the passage of current and thereby produce the discharge. So, radiation obviously increases with the current density. Higher the current density, you have higher radiation of ultraviolet light which impinges on the phosphors coated in the interior of the glass envelope, which we call tube. In fact, colloquially we refer to these lamps as tube lights. The low temperatures, there is some problem, pressure drops and the mercury does tend to condense. Now, recall in usage of the gas lamps, in order to ionize, we can have small amounts of rare gases included which have low ionization potential, and that aids the vaporization of the main gas and creating the. So, reasonably high temperatures there is less problem, and in fact commonly we have the hot cathode tubes. Now, let us have a look at the light output versus the lamp temperature shown here. We find that this is in degree Fahrenheit. You recall there is a shaded zone which is marked as the operating range of standard lamps at normal room temperature. You can say normal room temperature is often considered, you can consider it as a comfort temperature for the human beings. It is around 25 degrees centigrade. Now, you look at this, it is around 100 degree Fahrenheit, which would come around 35 to 36 degrees centigrade. So, you look at it this way, this is in terms of the gradient with the normal temperature is also not very high. If you have a very large gradient, there is a large amount of heat radiation, and that would necessarily increase your air conditioning load. In fact, yes, you can, by choice of the appropriate physical process and lamp source, one may achieve good illumination levels at low energy consumption, but at the same time any lamp that is employed, its heat output needs to be considered because it is going to add to the air conditioning load. Here once again, though we are talking about the various alternatives, the building design should always include the ability of exploiting the natural light to the extent possible by suitable design of the openings, both from lighting point of view as well as the air conditioning load, because ultimately every watt of energy saved is a useful resource. Now, one could observe that if you have around 80 to 100 is when you have the maximum light output for these lamps, and we are operating these lamps around the zone where the light output is around 80 to 90% of the maximum possible. This is the bulb temperature which can be felt at the, and soon we will look into how every watt of electrical energy pumped into this fluorescent lamp gets converted into light, heat, and how it is propagated out or how it is spent. See, this is the efficiency of a 1.5 inch dia lamp. It is marked T2, 2 into T2, and it is believed to be operating at a current of 0.41 amperes. The light efficacy for this is found to be around 80 lumens per watt, and one can observe that this curve is between the relative efficiency and lamp length in inches. Now, you see the curve begins with somewhere around 40 to 45% of the maximum possible light output, say around 10 inches, that is well beyond 4 to 5 diameters. Here the diameter of the tube is taken as 1.5 inch, and 4 diameters would come to around 6 to 7. So, 4 to 5 diameters beyond that, and as we go along we observe it's well above 80%, somewhere around 80 inches. 80 inches would essentially mean about 80 inches is around 1.6 meters. That is the kind of a length. Now, it also says that if we had this tube of a very long length, if the length be infinite, the overall efficacy which is estimated is around 80 lumens per watt. Now, here I must mention the two standard ratings of the fluorescent lamps which are in use. One is a 1 foot one, another is a 3 feet one, each rated for 20 watts and 40 watts respectively. Now, let us look at a typical 40 watt fluorescent lamp, which most of us, in fact, we find the 40 watt lamps are extensively used all around in our offices, invariably in illumination systems consisting of more than one tube in one luminaire, and 20 watts we find in most of our transport systems, railways, buses, probably aircrafts. Now, if you look at the fluorescent lamp, the out of the 40 watts that is got in, by virtue of your thermal, because we have hot cathodes, there is a initial light only about 2%, but around 24 watts is used in exciting the ultraviolet radiation. We said we are using the low pressure mercury vapor lamp, which is allowed to have peak radiation around 253 nanometer wavelength, which corresponds, and so what does it mean? Around 60%. This is the beauty of this particular lamp. Otherwise, we talked about the light utilization factor. We found of the two discharge lamps, mercury and sodium, which are extensively used, sodium has had a better utilization ratio because most of its energy radiated was in the yellow orange band, which was close to the eye sensitivity peak. Out of the rest, about 15 watts goes essentially in heating the electrodes at the two ends, and this is what is responsible for the temperature rise of the bulb, which we were talking a little while ago. Now, of these 24 watts, around 16 watts still, what happens to this 24 watts of UV light? It is converted into visible radiation, and there is a associated heat evolution, which can be split as 7.3 watts of light, that is through the process of fluorescence. We have had a good look at the various fluorescent powders, where the two issues which come up, one is the range over which fluorescent powder absorbs the radiation energy, and the zone over which it re-radiates. Both had their own peaks. So, we have about 7.3 watts. That means, what does it mean? If I pump in about 40 watts, 7.3 watts through the fluorescence, about 0.9 watts directly, that is a sum total of about 8.2 watts is what really converted into the useful light, and close to about 31 watts gets in as heat. But the advantage, remember, if we had used an incandescent lamp, most of it is only through its heat that light is produced. So, the essentially we get about 8.2 watts and 20% of the energy is being used, and color of course depends on phosphorus used. To some extent color can be altered by way of the usage of appropriate what you call the envelopes. The radiated heat is around 10 watts which goes along with the light. So, if one looks at the heat on the task table, this is the kind of a thing which one could expect along with the light. This together accounts for 50% almost. Convection and conduction are responsible. They could be controlled by proper design of the luminaire as a whole. So, this is what tells us how we are able to effectively use the energy pumped in. So, this is the distribution. So, what does it say? 20%, close to 20% is what comes out as the useful light output. Around 27% gets radiated as heat which goes along with the light, and about 53% is by conduction and convection. So, if we have small difference in the temperature between the temperature of the bulb and the ambient, there will be less scope for conduction and convection. Applications per se, if you look at, this is one application we thought of UV radiation, but there are other applications. All of us are aware these days. In fact, you can't think of drinking water anywhere, and water purification systems are rampant, and therefore UV is used for purification of water, and it does essentially by detoxifying the bacteria. And there are certain other therapeutic applications where the diseases like rickets are taken care, and colds, TB and anemia. However, the UV is beneficial only in small quantities. This has to be borne in mind. The exposure to the two vital organs concerned with our circulation and detoxification in the body, the heart and kidney, are to be avoided. So, we do find good use. In fact, this is how the lamps employing radiation in the UV zone used for therapeutic purposes are called black lights, because you do not see any visible light, but it does give some radiation which is beneficial. Industrial dye and food preservation is done. In fact, it is believed food preservation industry is able to preserve the food over long periods by subjecting it to these things, and the vitamin D production is enhanced by subjecting to small quantities of these things, and it is believed a peak of radiation centered around 260 nanometers is highly useful for as a germicidal, and is a peak around 296 nanometers peak is used as erythemal application, and 253, which is close to what we are using in your fluorescent lamps for illumination. In fact, fluorescent lamp, after it is radiated, is reconverted into the visible zone by the help of the phosphorus coated on the interior of the lamp. If we do not have any of this phosphorus, this light is what we would call black light, and this is used for therapeutic purposes, and it could be for any of these applications. Let us look at the relative efficiencies of the lamps for varying diameters with respect to their lamp current. And what do we find? We have here lamps marked from T5 to T17. There are two particular lines marked which are 40 watt and 100 watt vertical lines. Of course, this figure supposes that the operating voltage is around 110 volts. That is when you get this kind of a current levels which are shown. See, it is around 1.4 amperes for 100 watts and 0.5 amperes for 40 watt lamp, and there is a shaded zone. Shaded zone is what we call for slim line. Now, here again we have the all of us have seen lamps which are called slim line. They are marked as 34 to 36 watts. See, the power level becomes very important because all the time for a light system, artificial light, we are talking in terms of the wattage, and for a benchmark or a comparison it would be the incandescent lamp. Recall, because that is the one which produces nearly close to natural sunlight as far as spectrum goes. Hence, it would be necessary to know, I would like to compare, let us say I take this lamp, how does it compare in terms of the light output, in terms of the ease of use, in terms of the color rendering, in terms of the burning hours, all these. Now, you do find 38 mm or 1.5 inches is a normal lamp which we have been using, and they are known to consume 40 watts. Now, here I must caution that this 40 watts is the power consumed within the fluorescent lamp or the tube. It has accessories. So, you have to add additional energy that is lost in the ballast, and probably this is where you have the advantage of having the modern electronic ballasts, in the sense that they avoid wastage of energy. The other thing is, you have slim lines which are called, they have typically 24 mm diameter. 24 mm diameter would mean it is about an inch, that is about you could call it, and consuming around 34 to 36 watts. You do have certain high power lamps of the order of 53 watts. Now, what we are trying to see is that when you are operating the lamps, say below 0.2 amperes of the current, you do not find much change in the relative energies or relative maximum efficiency of the lamp with the length for all the diameters that are considered. You have T5 to T17 if you see. Let us say I consider an ordinary 40 watt lamp. If I use T12, T12 corresponds to T12 into 1/8 is a 1.5 inch diameter tube. What is the output I have? If I operate around 0.4 amperes, I have output the same as 89 to 90% to as that of a lamp of infinite length. That is the issue. But as I come closer, you find the change. Let us say you go around 0.2 amperes, whether it is T12 or T7, I would have similar levels of this thing. Now, why this is necessary? This is necessary because we looked at how the length to diameter is maintained constant, and it also looks at applicability of using a particular source that is available. We want to have optimize all these factors. Now, the other issue which comes is the virgin lamp has certain light flux output. How does it maintain during its life? If you recall, typical 100 watt incandescent lamp which we use these days is talked in terms of at least 1000 hours of burning, and you take any of these other lamps, the fluorescent lamps, they are claimed to have few thousand hours. So, what we observe is that there is a rapid fall of light output initially, but somewhere around 3000 to 4000 it tapers and it maintains around the same level, which is around 70%. This is a very important issue. That means if I take a lamp which has say 1000 lumens in a virgin state for a very long period, assuming other factors like the phosphor coating remains, filaments are stable and intact, the lumens or the light flux will be maintained reasonably around 700 lumens. That is the thing which one can interpret out of this curve. The other issue which comes is how many of them really have. If we start with the, as you can see, 80% average life is maintained by close to about 75 to 80% of the initial units that are developed. That means you could expect around 10 to 15% of the units to fail faster, and this is what we found even in the case of our incandescent lamps. So, this becomes necessary especially when you are having large number of systems. We did mention in the beginning that we could view a fluorescent lamp as a line source of light, an incandescent lamp as a point source of light. We found the illuminance due to a fluorescent incandescent lamp is inversely proportional to the square of the distance, because it is a point source, and it would be inversely proportional to the distance in case of a fluorescent lamp because it is a line source. Now, going by similar thing, one could show if you have large number of line sources placed close to one another, they form a plane. A plane of light source would make light flux independent of the distance. So, going by this, supposing I had to illuminate a table using a point source or a line source, I may have to resort to have lower distance of separation between the ceiling and the working plane, but it may not be required in the case of a use of a plane source of light, which can be got by having a matrix of incandescent lamps, that is large number of rows and columns of incandescent lamps, or the fluorescent lamps. And that is where, when you need to have such large number of lamps, the motility curves become very important. One has to look at such curves given by the manufacturer in order to understand when does one do the replacement, because if one has to do replacement of lamps one by one or unit by unit, it is going to be not cost effective. If one has to make it cost effective, it has to be done wherever there are large number of lamps involved, it should be a group replacement, and based on such mortality curves that tell us if we compare the fluorescent lamps, we have conventionally varying. In fact, you have tiny fluorescent lamps which can give around 4 watts. They operate anywhere from 150 lumens for a small one to about 5300 lumens for a large one, consuming about 65 watts. These are available in terms of energy savings. I did mention that saving of energy has become a key word these days. In fact, one way of achieving this has been to go in for smaller diameter tubes which with more efficient phosphors and better filament electrodes. They also give similar levels of light flux, but with similar efficacies, but consuming lower. If you consider a conventional fluorescent lamp which we have been using, standard one of 40 watts, can be replaced conveniently using this energy saver units around 24 to 28 watts. At the other end, for the higher power rating, we get 54 watts, and they are so designed that, remember, in the fluorescence, though the radiation initially is a band radiation, by the process of fluorescence it is converted into a visible zone. So, it has a warm white color with a good or excellent color rendering, whereas reasonably good color rendering, CR here denotes color rendering, is possible with energy savings. Now, this being a discharge lamp, it did require a accessory to create the discharge by way of enhancing the voltage, which we call as a ballast, which is reactive in nature, as a choke, which is being replaced by what we call electronic ballast. We will take it up in the control aspect, whereas most energy savers come with an inbuilt ballast. The other issue is there is some, if it is a reactor or an inductor coil, it does have certain resistance and it does have some heat dissipation. So, as a rough idea, one can attribute total energy consumption of a 40 watt lamp to be around close to 60 watts, whereas this is minimized in an energy saver unit. Continuing with that, of course, these two lamps these days are possible with very little run up time or restrike time, unlike your conventional mercury vapor lamps or sodium vapor lamps. And the conventional fluorescent lamps are possible to have with a burning life of around 5000 hours. As already told, you have the standard length of standard ones which are 38 mm in diameter and slimline variety with 28 to 26 mm. Now, here the idea of putting cost figures is to get a relative comparison. You have 5000 hour burning life as against energy saver having about 18,000 hours of burning life. The total unit along with the accessories may come at today's cost around 400 rupees, whereas lamp alone in case of energy saver would come around 1000 rupees, and the diameter of course is 20 mm, remember that. Replacement point of view, fluorescent lamp, the conventional one, the tube alone costs about 40 rupees. So, it is the initial cost is quite high, though the energy saving is there, but because of its long burning life, it may it outweighs in the long run. But keeping in mind the mortality rate, one has to look at. Now, the other thing which is coming up is what we call compact fluorescent lamps. Now, imagine being able to get high efficacy low pressure mercury vapor lamp to be used in the same outlet where I was using an incandescent lamp. That is the issue. And in fact, that is why most CFL parameters are compared with a typical 100 watt lamp. 100 watt lamp is more or less a standard lamp as far as interior lighting goes. So, you find you do get CFLs with the range of light flux between 600 to about 4800. They also have good color rendering, and as the name implies, it is a compact thing, which means it has got all the accessories. We talked about a starter, we talked about a ballast. Ballast is nothing but an inductor which enables to maintain the constant current nature of the arc, and it also enables a high potential initially to give the discharge. So, you find the from the light efficacy and light output point of view, typically a 18 watt lamp is known to give similar light output as a 100 watt lamp. And continuing with the further properties, you do find they are really comparable. No doubt, in today's market, a simple 18 watt CFL may cost around 150 to 200 rupees, but it has a long burning hours of 8000 hours. And the most important advantage of a CFL is it can go into the traditional incandescent lamp outlet, which we call as a bulb holder, the same thing. That is the beauty of that. Okay, there are some units available much cheaper also, but reasonably good CFLs are available around 150 rupees. Now, this shows a typical CFL with its all dimensions to be operated on normal 220 volt thing. The 100 volts which we are talking about here is the drop across the fluorescent element. In fact, you need to have, remember one thing we said, the light output is not a maxima at the ends of the fluorescent tube, it is few diameters away, 5 to 6 diameters. So, to get that kind of a length, you have a spirals placed. We have seen, all of us have seen, and this is known to have about 8000 hours of burning life with 1200 lumens output. All the dimensions are given. As you can see, this fits into the standard bulb holder. The only one objection with this kind of a lamp may be the intense the envelopes have not improved to that extent, in the sense, unlike a conventional fluorescent lamp, the light is not comfortable and the glare levels are high, and therefore, as it is found to be used in a naked form, it should be avoided. They are good if they are used together with proper diffusers, 1. 2, when placed in a recessed luminaires, that is recessed holders, the ceiling, they are very good. This is equivalent to a 100 watt incandescent lamp, and it can have, whereas an incandescent lamp has only 1000 hours of burning life, whereas that would be comparable to a 20 watt lamp which has about 5000 hours of conventional. So, this is the comparison one could have for a 18 watt CFL, and this notwithstanding, we do have a a category of fluorescent lamps which are called rapid start or instant start. This is achieved by having the heaters placed at the two ends and the special cathode elements that are used, and together with small amounts of ionizing gases, rare gases placed, so that ionization potential is low and quickly enables the lamp to go into discharge mode. This is now one has to have long thick pins are used for the lamp cams and the sparks surface contact, maximum surface contact avoids the sparks should not be there. And another one danger which we have, because it is supposed to be operating at a low pressure, in sometimes at the end of the thing, if there are strong sparks, there is a tendency for the lamp to explode. This is a standard lamp how it looks. So in effect, what we have seen today is the low pressure mercury vapor lamps which are used as fluorescent lamps are specified in terms of what we call T sub n. N gives us the diameter, n into 1 by 8, like T8 if I say it is a 1 inch diameter, that is the thing. For a given current and tube diameter fluorescent lamp, we have voltage proportional to the length obviously. Now one needs to have long lengths essentially because the radiation is a maxima not at the ends of the electrodes, but it is few diameters away from the electrodes, 6 to 7 diameters. It is inversely proportional to the diameter, so that is a thing, but there is a tendency to go in for smaller diameters and inversely proportional current through the discharge tube. By a T12 we mean that it has got a diameter of 1.5 inch. Radiation output from a fluorescent lamp is proportional to the current density in the tube. This fluorescent lamp emits considerable amount of UV and IR radiation along with visible radiation, and UV radiation is beneficial in small quantities. There are other applications like purification, detoxifying bacteria, curing of diseases, dye and food processing employed in producing vitamin D in food sources. CFLs are compact, efficient, energy saving and have lifetime but reasonably good color rendering. I said color rendering is not so good. All the accessories are inbuilt and therefore they are usable in the conventional lamp holders where incandescent lamps were employed. What do you mean by a T16 tube light? Why is hot cathode discharge tube preferred? These are some of the tutorial questions that can be addressed from this lecture. Preferred than cold cathode discharge tube. Why is it desirable to operate fluorescent tubes at room temperature? What are three categories of usage of UV radiation? What are rapid start and instant start fluorescent lamps? Precautions taken to use fluorescent lamps in explosive environments. Questions asked in the previous lecture, there are some of the answers to them. What are halide lamps? These discharge lamps contain some additives like indium, thallium. The mercury vapor lamps, why are they preferred than sodium vapor lamps? Mercury vapor lamps have a good color rendering while sodium vapor lamps are monochrome. However, sodium vapor lamps are being used extensively because of their high utilization of their radiation. Working principle of a fluorescent lamp. The energy of the UV radiation from a low pressure mercury lamp is directed on luminescent materials or phosphors. These in turn give out radiation in the visible zone. For what wavelength do we get a maximum efficiency of a fluorescent lamp? The maximum sensitivity is around 253.7 nanometers. How do we obtain reliable starting of fluorescent lamp? By having preheated cathodes or hot cathodes. What are the voltage drop at the electrodes and the choke for a fluorescent lamp? The choke, the voltage drop is half the operating voltage. If the cathode is a hot electrode type, then the voltage drop is around 14 to 16, And if it's a cold cathode type, it's around 70 to 100 volts. Thank you.